Alright, so we continue with the petroleum generations for the natural gas. Okay, so natural gas is one of the other forms of petroleums, right? That is refers to the gaseous phase of petroleum, which does not condense at standard temperature and pressure. Okay, why do we need to know this? Very simple. Okay, you need to refer with the current situation. Okay, so currently, natural gas has become the world's major fossil energy. And at this moment, right, world resources of unconventional gas from tight gas, tight sandstone, black shale, coal, hydrates are likely far exceed the conventional resources. Okay, so in the oil field, normally this natural gas is usually classified as dry gas or methane if it has less than 1.3 liter per 100 meter cubic. Meanwhile, it is classified as a wet gas if it is more than 4 liters per 100 meter cubic. Okay, so whatever in the subsurface, right? Gas that we call normally that deal with our area is we call as reservoir gas. That means the gas that occupy in the reservoir rock. Okay, so in general, reservoir gas is occur underground in the free gaseous state or as a gas dissolved in oil and water. Okay, so a typical reservoir gas usually contains methane, which around 70 to 100%, or we call as dry gas. Okay, and in reservoir gas, it also has 1 to 10% of ethane, propane, and butane. Okay, as well as there are also lower percentage of higher hydrocarbon through hexanes, right, and above than hexanes. Okay, there is also a non-hydrocarbon gas that vary in composition. We can find it between 1 to 100% of carbon dioxide, hydrogen sulfides, and nitrogen gas. So for hydrogen sulfides, normally if you find it in a high intensity or high concentration, right, in the oil field, normally we call it as a sour gas. Meanwhile, if you find it's a low intensity or low concentrations of hydrogen sulfide, so we call it as a sweet gas. Okay, for under reservoir gas, so we do have first associated gas and non-associated gas. So associated gas is any gases that occur, right, with oil as free gas, gas dissolved in oil, or liquefied gas, means in condensate. So normally this free gas can occupy in pores and natural fractures. Okay, and then next we do have a non-associated gas. That is a gas that occur alone as a free gas, and as a gas dissolved in water. Okay, so meaning that at the subsurface, okay, with pressure beyond 4,000 psi and temperature above 93 degrees Celsius, right? Most of the oil fields, okay, it might containing hydrocarbon gases and oil that exists as single phase petroleum fluid with gas dissolved in oil or gas dissolved in water. Okay, as I mentioned in the previous lecture, methane is the simplest hydrocarbon compound, right? So methane has been occupied abundantly, right? Has been found occupied abundantly in accumulations of petroleum reservoir. Okay, so you can see here that there is a markedly show high percentage of volume with almost 90%, right, of methane that has been found in the crude oil. So crude oil, while the high molecular weight of the hydrocarbon, okay, the other hydrocarbon like ethane, propane, butane, nitrogen, and carbon dioxide, right, it's contribute in low volume of the crude oil itself. Okay, so Although methane has been found abundantly in the crude oil or condensate, please bear in mind that under normal hydrostatic pressure, right, this methane will fills only 1% of space it occupies at the surface. Why? Because of the characteristic of that gas. Okay, gas is highly compared to oil and water, right? Gas is highly compressible. Okay, meaning that if you have two equal size of gas reservoir, right, at different depth, for example 2000 feet and 1000 feet meter square and 1000 feet, the latter reservoir will hold roughly 5 times as much as gas as the former. So meaning that as the deepest reservoir rock, right, will hold most of or will hold higher volume of gas compared to the shallower reservoir because of the presence of increasing in pressure, right? As pressure increase, it has the ability to compress, right, the gas in the space that it occupies. So it will create more space for another batches of gas to be accumulated in the reservoir itself. Okay, other characteristic of gas, okay, compared to oil and water, gas is also very mobile in the subsurface. Therefore, it has been found widely distributed vertically and laterally than oil because it migrates more easily. And also, it is generated from the source rock that are more widely distributed than source rock of the oil. For example, coal deposit worldwide, okay, which one of the source for hydrocarbon gas, contain thousands of trillion cubic feet of gas in place that are actively being drilled and more are waiting for the economic of production. Okay. Part of the gas characteristic is that gas is ambiguous in petroleum basin. It means that it is always generates and expels as long as there are active hydrocarbon generation kitchens or source rock. Okay. Okay, both of the hydrocarbon gas and non-hydrocarbon gas, okay, in natural gas have multiple sources. Okay, means it's come from many of the origins. Okay, the major sources of the hydrocarbon gas are all come from the biogenic, both for hydrocarbon and non-hydrocarbon as well, which they come from the decompositions of organic matter in the earth crust. So for the biogenic, right, we do have 4 sources. First is from the methanogenic bacteria process, right, from all types of carcinogen. Second, and the third one is from the coal itself, and fourth one is the oil in source and reservoir rock. So in general, the process to form hydrocarbon gas from source number 2 and number 3, okay, we need help of the high temperature to crack the carcinogen and coal to generate methane, right? And this time you call it as primary cracking. Okay. Meanwhile, for the hydrocarbon gas to form by the source number 4, we still need temperature, but this time we need more temperature to crack the existing oil and any oil that still remain in the source rock and reservoir rock. So this time we call as secondary cracking, right? Okay, for non-hydrocarbon gas, it can come from both biogenic and inorganic process as well. Alright, we go one by one for each of the sources. Okay, for the bacteria sources or methanogenic bacteria. Okay, so methanogenic bacteria here is refers to all methane that are formed or that are sourced from biogenic organic matter. So this process usually occur in immature species or during diagenesis process. Okay. and it is formed in the or at the surface at temperature with standard temperature and pressure, okay, within 20 to 80 degrees centigrade. So the process is actually favor for bacteria to survive in that bacteria can survive only in anosmic environment. Okay, means that the bacteria only active and survive in the condition where there is an absence of oxygen. Okay, so in this condition, there will be two reactions or processes that occur in generating the hydrocarbon gas. The first one is microbial fermentation, in which bacteria that exist in the organic matter, right, will be fermented, okay, and produce hydrogen and carbon dioxide, which the hydrogen later will be consumed, okay, by the bacteria, okay, through sulfate reductions until much of the sulfate is gone, and later will generate methane. Okay, so this type of process it can occur either in the water column or in the sediment itself. Okay, second process is by the reductions of carbon dioxide. So once bacteria, okay, consume the organic matter through the fermentation process, right, it will generate the carbon dioxide, and through that carbon dioxide, okay, there will be reduction process, okay, we call it as carbon dioxide reduction process, which this process occur when bacteria form methane, reduce the carbon dioxide content in the sediments and water column, and later it will form the methane from the bacteria by the process. Okay, so it means that this methanogenic bacteria, it will be more prefer to utilize the lighter hydrogen rather than heavy hydrogens. Okay, and as a consequence, methane that are formed from the bacteria source by this process will be very deficient in hydrogens. Okay, next, from the corrosion types, okay, the hydrocarbon, remember the hydrocarbons and non-hydrocarbon gases can be biogenic source from all types of corrosion. So you can see here, this is schematic illustrations that shows the various gases from the different temperature ranges. So this curve shows you a very general way of the relative volume of the gases that came from the organic matter, from type 1 and 2 sapropylic source, and from the humic source. Okay, remember I did so basically through this illustrations diagram, right, there are three types of gas that will form from the corrosion types. So first is the dry bacteria methane, right, during diagenesis, and then when the temperature increase from 50 to 200, right, there will be wet thermogenic gas, okay, that will be produced, and then lastly, at the same time, there will be dry thermogenic methane that will be produced during the catagenesis process. Okay, so for during diagenesis, basically there will be bacteria methane or dry bacteria gas that is formed in the surface temperature in the surface sediment from 20 to 80 degrees centigrade. So this bacteria gas is actually estimated to present 12% of total methane in non-reservoir gas, and possibly to 20% of methane in conventional reservoir. But this amount of early methane in shallow reservoir can easily lost, because shallow reservoir generally will have no effective seal rock. That's why it come out to the surface. Okay.